Hi everyone, thanks for joining us today. Today we're going to be spending some time on using the Chroma 61509 for immunity testing to IEC 61000-4-13. We'll begin the video by going over some of the connections to get the 61509 operational. Then we'll take a look at the software, and finally we'll go ahead and run a test. The Chroma 61509 provides testing capabilities for the flat curve test, overswing test, sweep and frequencies test, individual harmonics and interharmonics, and the Meister curve of IEC 61000-4-13. These tests are run using the software, which is ordered as a soft panel. This source also provides capabilities for IEC 61000-4-11, IEC 61000-4-14, and IEC 61000-4-28. Let's go ahead now. Let's get the unit turned around and walk through the necessary connections in the back to get the system operational. Here's the back of the Chroma 61509. There's only a few connections that need to be made to get the system operational. The first of which, in the lower left-hand corner, is the power input. Right next to that, in the right corner, we have our power output. The final connection we're going to be using is going to be our USB connection, kind of in the top center of the unit, and that's going to be going to our computer. For additional information about the connections on the front and the back, as well as a system overview, go ahead and check out the other video we made, which I'll put a link for in the description below. Let's go ahead now, let's get the system started up, and let's take a look at the software. Here's the starting display on the software. As we take a look, we have the testing capabilities and standards along the top. This is the fixed menu we're looking at now, where the voltage, frequency, and other parameters that will be used during the testing will be set. This menu is fairly straightforward. You have the ability to select AC, DC, or AC plus DC on the right. Below that, towards the center, is where you can select the voltage, frequency, limits, and waveform. If we take a look to the right of that, you have the voltage range selection, and then finally, all the way on the right, the output status. We're just going to leave the default values entered for the time being. We're interested in IEC 61000-4-13 testing today, so let's go ahead and let's take a look at that menu. Here's the IEC 61000-4-13 starting menu, and we're looking at the flat curve test. As you can see, along the top we have 4 different tabs for flat curve test, overswing test, sweep and frequencies test, individual harmonics and interharmonics, and Meister curve. These tests will also include classes based on the underlying requirements if they're provided. Looking below the tabs, we have gray text, which indicates the voltage and frequency that were set on the fixed menu, which we looked at just a second ago. This menu can be accessed by clicking the back button in the upper right-hand corner. On the left side, you can see we have the output waveform graph, and below that, our run bar. To the right of that, we have the classes and user-defined class. Below that, we have our runtime output status and trigger. When the output status is on, the power levels will be provided from the fixed panel, and when the trigger is pressed, the test will begin. On the bottom, we have a series of graphs showing different criteria, which can be adjusted with the drop-downs next to them. The overswing test menu will look very much the same as this menu for the flat curve test. Let's go ahead now and take a look at the sweep and frequencies test menu. Alright, now we're on the sweep and frequencies test. This test sends an interharmonic waveform. As you can see, this menu is slightly different and will look similar to the Meister curve. Let's go ahead now and let's spend some time on it briefly. On the left, we have 2 graphs, one for the fundamental frequency and below that, the current. As we work our way right, looking at the top, we have the interharmonic frequency, and below that, the time counter. Next, the different classes, including a user-defined class. Finally, below that, we have a series of indicators used to display the percentage of interharmonic level currently being used. Below that, we have an output waveform graph simulation. Finally, we have our output status and trigger. Let's go ahead now and take a look at our fundamental frequency graph. As we switch from one class that we're on right now, user-defined, to class 1, you'll see the values change. And then if we switch that again to class 3, you see those values on the graph change again. Now let's go ahead, let's spend some time on the individual harmonics and interharmonics tab. This is the third style of menu, and as you can see, we have a waveform simulation graph in the upper left corner. To the right of that, a series of tabs for individual harmonic and interharmonics. Right now we're on the individual harmonics. This tab has multiple options for odd and even harmonics, and within those, classes 1, 2, and 3, as well as user-defined levels. Below that section, on the bottom, we have the individual harmonic percentage and time simulation graph with criteria and output status trigger as well. If we click on class 1 to class 3, you can see there is a significant change in the waveform graph simulation. There we are, just like that. Let's click the interharmonics tab now, and let's take a look there. As you can see, there's capabilities for both 50 and 60 Hertz. Just as with the other tabs, we have different options with different classes, as well as a graphic display along the bottom. Let's go ahead now and run a test. Here's the flat curve test again. Let's go ahead and modify some testing criteria and run a test. Let's go ahead and click the user-defined testing criteria in the upper right corner. And let's go ahead and modify our clip waveform percentage to 50%. Then we're going to hit enter. Just below that, we have our runtime. It's currently set at 500 seconds. Let's go ahead and change that to 30. And then we'll hit enter. Let's be sure now that our output status is selected in green. And then let's go ahead and select the trigger to run the test. All right, and as you can see right now, our run bar is moving across the screen. Let's go ahead, let's let the test complete. Then let's take a brief look at the waveform from our oscilloscope, just being sure we're getting what we would expect. All right, here's the scope trace, and let's just look at it briefly as a quick functions check. You can see the waveform does seem to be clipped at about 50%. All right, that should complete the video today on using the Chroma 61509 to conduct testing to IEC 61000-4-13. We began the video by walking through some of the connections to get the system operational. Then we spent some time on the software, and then finally we went ahead and we ran a test. We hope this video has been useful, and please keep us in mind if you ever need to rent the Chroma 61509.